Alrighty, my friends, let's go ahead and figure out some answers here. If x plus 5 is a factor, that means if I plug in negative 5, so that means f of negative 5 is 0. So I'm going to write 0 equals, I'm going to put negative 5 in everywhere I see an x. A times negative 5 cubed, 23 times negative 5 squared, minus 7 times negative 5, plus 15. I'm going to go ahead and do those powers. So that's going to be 625 minus 125a plus 5 squared is 25. And then 23 times 25 is 575. 7 times 5 is 35 plus 15. I'm now going to combine like terms. So all of those numbers I'm going to put together. And I'm going to have 0 equals, I just had a thought, but I stopped myself. 1250 is what that combination is, minus 125a. I'm going to go ahead and add the 125a to both sides, just because I want to be positive, because, being positive is good. And now I'm going to divide by 125, and I'm going to get a is 10. If I plugged a in right here, if I put 10 there, if I then plugged in negative 5, I better get, negative 5 for x, I better get 0 for that side. This one, a function, one of its factors is given. So let's go ahead and use long division. So 6x cubed minus 18x squared plus 7x minus 21, x minus 3. So my first question is x times what is 6x cubed? That's going to be 6x squared. Distribute that 6x squared to the x, and you get 6x cubed. Distribute that 6x squared to the negative 3, you get negative 18x squared. Subtract down. Oh, look, you get 0. So I need to bring down both the 7x and the 21. Now my question is, x times what is 7x? So that's going to be 7. That's going to be 7x minus 21. Subtract, I get 0. That's a good thing because we're dealing with factors. So our new factor is 6x squared plus 7. If that was a quadratic that we could factor, then we could do some more work. We can't factor that. In fact, that doesn't have any real zeros, so we couldn't find any more real zeros. The only real zero would be if x were 3. Without using calculator, sketch each function. Indicate the domain, range, vertical, and horizontal asymptotes, and y-intercept for each function. Okay, so there's a bunch there. The domain, okay, so domain has to do with, okay, what makes the bottom equal to 0? There's a couple different ways to think about these. Here's what I want to do. I want to think about it. I'm going to try to be consistent with how I think about it. I'm going to graph x plus 6. So that's going to go like this. So that's the graph of x plus 6. Wherever that hits 0, I'm going to have a vertical asymptote when I do the reciprocal. So that's going to be x equals negative 6. That means x cannot be negative 6 for the domain. And that's the only place we have an issue. The y-intercept we'll get to, so let's see. So now, as x gets huge, you should recognize that this curve is going to go to 0. And since we're doing the reciprocal, see how we have positive stuff here and negative stuff here? I could be more specific, but basically your swoop's going to be like this. You're going to have a positive swoop, and then you're going to have a negative swoop. Let me draw. There we go. Negative swoop. So something like this. The horizontal asymptote, therefore, is y equals 0. It often is with these, the ones that we've explored so far. And then the range is y cannot be 0 because we do not cross through y equals 0. We have that horizontal asymptote, and we don't break through that. For the y-intercept, I would just plug in. So the y-intercept is when x is 0, so 0 plus 6. So that's 2 over 6, which is 1/3. So the y-intercept is 0, 1/3. Obviously, I didn't do a great job on my graph of where that was, but that's okay. It's just basically a sketch. I would prefer actually this graph to not have numbers on it or grid lines. Similar idea on the next one. I'm going to go ahead and graph x squared. So x squared goes like this. So when we do the reciprocal of that, we're going to have a vertical asymptote at 0, because that's where the curve hits the x-axis. So if we do the reciprocal of that, we are undefined. You notice how we have positive y values and positive y values? That means our graph's going to look like this and like this. But wait a minute, I messed up, didn't I? Because I didn't pay attention to the fact that there was a negative 4 on top. So that's going to be a vertical stretch. So I guess I could have left what I did, but then the vertical stretch is going to make it go down here more. It's going to flip it over because of the negative, and then make everything be farther away. And again, I sketched it. These should be the same on both sides. Not a big deal. So the domain is going to be x cannot be 0, because that's where we have our vertical asymptote. The range here, you got to be careful. The range is actually y is less than 0, because I can't cross that x-axis. Vertical asymptote we already established was x equals 0. Horizontal asymptote is once again y equals 0. And then the y-intercept. So the y-intercept, we plug in 0 for x. Oh wait, we can't. So there isn't one. So none. Boom, did those. There are other ways to conceptualize these and think about these. If you are confused, feel free to ask questions. Vertical asymptotes, you could consider just setting the bottom equal to 0. One way to do it. Horizontal asymptotes are what happens when x gets huge. So think about dividing -4 by increasingly huge numbers, and that will go to 0. Write a rational function, okay? I see I have a vertical asymptote at x equals -4. So my function could be y equals 1 over x plus 4. Your explanation, I'm going to do a verbal one, you need to do a written one. My explanation is I can't pinpoint necessarily any of the other specific points on this curve. Maybe I could say I can go through there, so -3, 1. So if I put in -3 for x, I get 1 for y, so that works. So I think I would do that. So my explanation is going to be, since I have a vertical asymptote at x equals -4, that means the denominator has to be 0 there, so x plus 4 is the factor associated with that. I then chose the point -3, 1, and if I plug in -3 for x and 1 for y, I get a true statement, so my function works. That is what my explanation would be. Again, you need to write that stuff down. You can put it in sticky notes, however you wish to write it. Next one, write a rational function. Domain is all real numbers except 6. Range is all real numbers except 0. Okay, so if we can't be 6, to me that says, let's put an x minus 6 on the bottom. If the range is all real numbers except 0, so that's like the horizontal asymptote, so I can't have an expression on top that would potentially be 0. I'm going to start with putting a 1 there. If I were to put in 0 for x, I get -1/6. So if I put 0 in for x, I get -1/6. I need to get -1/2. So if I have -1/6, what do I need to multiply that by to get -1/2? Hopefully you can see that pretty quickly. I'll write it like this for you if you'd like. If I do 1 over 3, no. If I do 2, I had the right idea. 3, I'm going to get there eventually. Sorry, my brain just fell out of my brain. My brain fell out of my brain. 3 over 1, that will get me 3 over 6, which is 1/2. I got there. So if I instead change the top number to a 3 instead of a 1, that now works. So my explanation is going to be exactly what I just did. My explanation is I cannot include 6 in my domain, so x minus 6 would be a logical thing to put on the denominator of my function. Since the y-intercept is 0, -1/2, I plugged in 0 for x, and I figured out what I had to put on top, also known as the vertical stretch or the vertical dilation, to get -1/2 as my y-intercept. I hope that makes some sense to you. As I said, keep saying, there's some other ways to conceptualize these things, so feel free to talk to us for further discussion, explanation, thoughts. If you have a different way of thinking about things, whatever works.